So when we look into 3.2, it has us look at it standard form. We've been dealing with the vertex graphing form, right? And 3.2 has us look into the standard form. You can see it right on the top where it says y equals ax squared bx plus c. So we have three different variables. We have, I shouldn't call them variables, a, b, and c. A being the coefficient in front of the x squared, b being the coefficient in front of the x, and c being the constant, the number by itself with no x's. Okay? So we're going to see what can we get out of these type of standard form quadratic equations. Okay? So we're going to do some examples together, and then you guys are going to do some examples, and we're just going to work back and forth amongst these functions and see if we can't figure something out. Okay? So we're looking for commonalities, we're looking for things. So the first one I'm just going to show you is done for you. We have this x squared plus 6x plus 8. The first thing I want to do is in the function I want to factor it, if we can. So do you guys remember factoring? What times what will give us the last number, the constant, and add to give us that middle number, the b, right? As long as a equals 1, we can go what times 1 will give us 8, and add to give us 6. That gave us 4 and 2. So my factored form is y is equal to x plus 4, x plus, and I'm just going to put the x plus 2 here, just so we can see that it's factored like that. The values for a, b, and c, well, a is 1, since there's nothing out in front of the x squared. B is 6, and c is 8. Now, can we get the vertex right out of the standard form? No, that's where comes our graphing calculator. In our y equals, if I can press y equals, I'm just going to clear here. So in our y equals, we're going to clear all of these right now, and we're just going to have y1, y2, y3, and it's all blank. We're going to type in our first function, so we're going to type in x, which is right here, right beside the alpha. Sorry. Clear. X squared plus 6x plus 8. Now if we hit graph, hopefully your windows are set 10, negative 10, 10, negative 10, and we can see, thank you, we can see that the vertex is right here, right? How can we tell where it exactly it is? We can guess that it looks like it's negative 3, 1. Do you guys remember how to find that vertex? Maximums or minimums. Is this a maximum or a minimum? It's a minimum. So we're going to go second, trace, and there's a minimum thing here, right? So I'm going to hit 3 for minimum. It says left bound. That means you have to be on the left side of the vertex. So you go all the way so that you know you're on the left side of the vertex. So till I start coming back up, enter, and then it says right bound. So then I go till I know that I'm to the right of the vertex. I hit enter, and then it says, what's your guess? So I go down to where I think the vertex actually is. I hit enter, and it tells me my vertex at negative 3, negative 1. Sometimes it has like decimal 0.00002 or something like that. Just take the negative 3. If it said negative 3.5, don't just say negative 3. But if it goes these zeros to 2, then we'll just say negative 3, negative 1. Okay, so now we have our vertex. How do we find our x-intercepts? Well, that comes back to here. Or we can set y to 0. But if we're doing it right off our graph, I heard someone say, does y2 have to be 0? Yeah, if we let y2 be 0, and we look at the graph, where those two lines intersect, where the line intersects with the parabola, that's the x-intercepts, right? So then we can go second trace intersect. Gives us 5, and then you take the little blinky thing and tell. That's right over here. And so we got an intersection of 0, negative 2, 0, and then I can go second trace intersect. And guess right about there. Gives us negative 4, 0. So then we have our two x-intercepts that we can write down. What about our y-intercept? That's right here, right, where it hits the y axis. That's when what value is 0? That's when x is 0, right? How do we find that? Is going into our table. Now, my table looks funny. My table setup must be funny. I'm going up by 1s, but I'm starting at 2.5. So if you're ever looking funny, you can always go second table set and start at 0 and change in table of 1s. And so now I can go second table. And when x is 0, y is 8, right? So you just have to find when x is 0, you can find your y-intercept. So we put it as a point 0, 8. Your axis of symmetry, we know from before, that's x is equal to negative 3, or x is equal to that x value of your vertex. So some things that you might notice, or some things that Jaden just noticed, is the y-intercept reflects something that's in the standard form. What does it reflect? The constant value. So as we carry through, we're going to see if that constant value matches up with that y-intercept, right? So that constant number in the back is 8. The y-intercept is 8 on this one, and we saw it in the graph. Did anyone notice anything else, though? Nothing? Okay, let's carry on into the next one then, and see, maybe we'll notice something. Did anyone factor this second one already? What times what will give us 5, and add to give us negative 6? Negative 5 and negative 1? Is that what you got? So if we write it in factored form, we get x minus 5 times x minus 1. What's our a value? And our b value? And our c value? Good. The next step, what were we supposed to do here next?
Find the minimum.
Find the vertex.
It says like 2.999 if you're trying to.
So then we might round it to 3. Let's take a look at this then. I'm just going to delete or clear out y1. I'm going to leave y2 at 0 because that will help out later. I'm going to type in x squared minus 6x plus 5. And then I'm going to go graph. Okay, looks like I'm still looking for a minimum. It's now over here. So if we go second trace minimum, we want to do left bound, enter. We want to do right bound, enter, and guess somewhere. And so it says 0.2999991, comma negative 4. So we're going to round that to 3. So it'll be 3, comma negative 4. The next step was to come up with x-intercepts, right? So if we're looking for x-intercepts, we're looking here and here. So we just go second, because we have y2 equals 0, We can go second trace, intersect, and go over here, and hit enter, and go over here.
This
Oh.
is Caroline. They won't let me click on my second curve.
Do you have y2 equals 0? If it's not allowing you to click on your second curve, sometimes your second equation's not written in. So it looks like I have an intersect of 1, 0. And if I go second trace, intersect, and go to the other one.
And couldn't you just do like x minus 5 equals 0 and then plus 5?
Good.
This graph is too much.
So Kaylin figured out that graphing calculators, however they can tell you the answer, sometimes they take too long. They're annoying sometimes. And can I tell you something? You're not going to have those babies forever, right? You don't get those in university, so don't become dependent on them now, right? So what we found out was it was 1, 0, and it's 5, 0. Those are our x-intercepts. Kaylin noticed an extra key point. She said, hey, over here when it's factored, if we set y to 0, we get x minus 5 equals 0, which is x is equal to 5, and x minus 1 equals 0, which is x is equal to 1. And what are those? Those are your x-intercepts right there. Why do we have to graph it and find them? If it's in standard form, if we can factor it, we can come up with those. We can't factor it, guess what? You have that quadratic equation that you can factor and come up with numbers if they're not factorable, the easy method, right? Or decomposition. So, are we happy with that? That's another good thing to notice. As we carry on, what about our y-intercept? Well, I can go in here and go second table and look where x equals 0. When x equals 0, y equals 5. So that's 0, 5. What did Jaden say already? He said, that looks like it's the y-intercept. What value is the y-intercept? The constant in the back. Okay? So do we need to go and look at where x equals 0 and find y on our graphing calculator? No. The equation tells us. We don't need that fancy thing. What's the last thing? It's the vertex, right? Is it the vertex? So if I ask you, no, it's not the vertex, it's axis of symmetry. So if I ask you to do the axis of symmetry, we get x is equal to, because it's an equation, but where do we put it? 3, right? The x value of your vertex. Are you guys okay? Can I leave you working on this? You can use your graphing calculator. You can use your factoring skills. Sometimes, can I give you a hint here? Like down here, x squared minus 6. Your c value is 0. You have no constant. Your constant is 0. You can factor an x out. So this turns into y is equal to x times x minus 6. So it might not just be what times what and what adds to what. You might be able to take a common factor out of things. Okay? Your homework today is to work on this chart. That's it. Good? And at the back page it says, what are some common things you noticed? Write down the key things. That the c value is your y-intercept value, right? Write down when you factor it, you can find your x-intercepts. Write down all those key things you noticed in two things.